Chapter 8, Section 1 deals with mountains and volcanoes. In Chapter 8, we're going to talk about how mountains form. When the rocks are moving, we talked about those plate boundaries moving around each other. When they run into each other, some of these formations that are formed occur when the continental plate would hit an oceanic plate maybe, and the oceanic plate can even get pushed up miles high in the air. That's why some mountains you can actually find seashells, fossils of sea creatures up on the top of the mountain. It wasn't because the water was that high, it was just because the rocks themselves got pushed up. Well, some of the terminology that we're going to look at in this section deals with mountain ranges and mountain belts. Most mountains belong to ranges. Well, these are vocabulary word right here. These are just long lines of mountains that were formed at the same time. Here's an example. We have these mountains here in the United States, and we have the Rocky Mountains right here. They're mountain ranges. If you look at a bunch of mountain ranges that are close together, they make up mountain belts. Like these, all of these are different mountain ranges, but you put them all together and they make a mountain belt. Most of the world's major mountain belts are located near tectonic plate boundaries, and here are those tectonic plate boundaries, and where most of these mountain belts are located. So if you start to think about some of the main ones, we know that the Himalayas are right here, and we know that the Rockies are here in the United States. The Andes are down here in South America. The Appalachians are also here, part of the United States. The Urals, right between Europe and Asia. The Alps, those are in Europe. And we can check to see if we're right. And I must not put them. Caledonian Mountains were up here, and I think, which one did I not put in? The other one, Tasmania, down in Australia. So, but that's where those mountain ranges are found throughout the world. Most young mountains, they're very rugged. They're pointy. Their peaks are jagged. You can see in these three pictures right here. They have steep slopes, they're tall, they're jagged. Those are younger mountains, like the Rocky Mountains and the Himalayan mountains. They're younger. Old mountains are older. They're lower because they've been worn down by the weathering, wind and rain. Stuff's been eroded. They're rounded. And if you look at some of these, like this guy right here is rounded on the top. These guys are rounded on the top. They're worn down, sediments down at the bottom of the valleys. So now mountains form, or can form, when rocks fold over each other. And it's kind of hard to imagine that a rock would fold because you think it's rock, it's solid, it's strong. But example right here, the formation of the Himalayan mountains occurred because it's on a convergent boundary. Continental collision occurred, and the rocks folded up. Folded mountains form when an oceanic plate sinks under the edge of a continental, or as a continental collides. At a convergent boundary, folded mountains will form there as well. Just because we just talked about oceanic, continental. Sometimes the volcanoes will form because of those subduction zones, and we talked about where the plate sinks under and it creates this excess magma and it pushes it to the surface. Continental collision begins when they start to run into it. They start to crumple, then they start to fold. Subduction stopped after continents collide. Once they collide, there's no more magma being formed. So you're not going to get the volcanoes out of them, you're just going to get the mountains. And as the collision continues, the crust keeps on folding and folding. And earthquakes are common because of the stress that's being built up in the rocks that are being bent. Sometimes you can find, or you'll find remnants of seafloors way underneath the mountains. Folded mountains are pushed up by the slow continual stress that causes rocks to gradually bend, and then they form when that continental crust is being compressed with one another. Mountains can form as rocks move along the faults, something called a fault block mountain. Well, if you look in your book on page 259, there's some pictures there that kind of show how it's done. Go on your online book and check that out. If you remember, you log in as your ClassZone.com e-services, and then, your website is ClassZone.com. Then you click on e-services. Then it's the 5 letters of your first name and the 3 letters of or 5 letters of your last name, 3 letters of your first name, and your password for most of you is your lunch number, then 597. Some of you have given you special ones because that wasn't working for you. And here's just an animation here of how mountains do form. And we'll watch this, I hope.
Well, you got that right. That is a pretty unusual mountain range. Dear Tim and Moby, how do mountains form? From Jack. The Earth's crust is made up of huge chunks of land called plates. There are 7 major plates and lots of little ones. These plates move around very slowly, and that movement is called plate tectonics. Mountain ranges form where plates shift, pull apart, or push together. Lots of times you can tell how a mountain was formed just by looking at it. Forces deep inside the Earth push the horizontal rock layers together to form folded mountains. When the rock layers are squeezed from opposite sides, they buckle and fold. Sharp peaks and ridges are signs of upwarped mountains. They form when forces inside the Earth push the crust up. Over time, the rock is exposed and weathered. Fault block mountains are made of huge slanted rocks separated by cracks called faults. The Earth's shifting crust pushes one plate up and the other one down. When molten magma is forced through cracks in the Earth's crust, it cools in layers. The layers form a cone shape over time, and that's a volcanic mountain. Okay, well, that's it for mountains. Have you got any other cool things to show me? No, I meant like cool natural stuff around here, like rock formations or never mind.
Okay, so hopefully you could see how fault block mountains were formed on that little animation. So now some of the review questions that you might want to think about trying to answer. How is the formation of mountain belts related to tectonic plate boundaries? How do folded mountains form? How do fault block mountains form? The Urals, which is a mountain range between Europe and Asia, are not on any tectonic plate boundary anymore. Would you expect them to be tall and steep, or would they be short and rounded? And explain why. And the last one, how can a mountain continue to be pushed up but not get any taller? That one requires some information from previous chapters. But if you can answer all these, you're doing well. If you can't answer these questions, you're going to need to go back into the book and look those up, or go back into the notes and try to see if you could find the answers. So this will be one of the activities that you have to do here. So for Chapter 8, I'm going to send you on your own, and you're going to end up doing a lot of this all by yourself. So make sure that you, after you've taken the notes for this and you've answered the review questions for this, you check them off on your list of things, your menu, so to speak, of things to do for Chapter 8. Oh, and I'll give 2 falcon feathers to the first 2 people that come to me and can explain the difference between a folded mountain and a fault block mountain. 2 falcon feathers for the first 2 people from each class to come and explain the difference between folded mountains and fault block mountains.